Welcome to qnawire.
To find the speed of each hydrogen atoms, which is needed to excite both hydrogens from the ground level to the level number 4 by head-on collision. So let's sketch the system. So let's say there are two identical hydrogen atoms moving towards each other. So then they collide, and it results in the excitement of each hydrogen from n equals to 1 to n final equals to 4. So basically it means that we have to find the initial speed of each hydrogen atom. So let's consider the conservation of energy. Before the collision, total energy of the system equals to sum of kinetic energies of two atoms. So it equals to 2 multiplied by mass of hydrogen atom multiplied by its squared initial velocity divided by 2, or mass of hydrogen atom multiplied by its squared velocity. So after the collision, all the energy is transformed into two energies of excitement. So it's 2 multiplied by energy of the transition from state 1 to state 4. So now let's calculate this guy. For each individual hydrogen atom, this energy equals to this energy equals to negative our Rydberg constant multiplied by negative Rydberg constant multiplied by 1 over n final squared minus negative Rydberg constant multiplied by 1 over n initial squared. Or we can simplify this expression. So it's going to be Rydberg constant multiplied by 1 over n initial squared minus 1 over n final squared. So which is going to be Rydberg constant multiplied by 1 over 1 squared minus 1 over 16 squared, minus 1 over 16, which equals to 15/16 of Rydberg constant. So now we can complete this question. So on the other hand, total energy of the system equals to 2 energies of these transitions, which is in turn 15 over 8 Rydberg constant, and it also equals to mass of hydrogen atom multiplied by its squared velocity. So therefore, initial velocity of hydrogen equals to 15/8 of Rydberg constant divided by mass of hydrogen, and it's all square rooted. So now we can complete this calculation. So I'm going to express Rydberg constant in joules. So 1 Rydberg constant equals to 2.1798774 multiplied by 10 power by negative 18 joules, and is divided by also by the mass of hydrogen atom, which is shown here. So it's 1.6736 multiplied by 10 power by negative 27 kilograms. So now we can complete this calculation. I'm going to use a calculator, and you can do it as well to double check the results. So it equals to 49,419 meters per second, or we can round it to roughly 49.4 kilometers per second. However, the previous answer is also correct because we have quite a decent amount of decimals for both constants, for the Rydberg constant and for the mass of hydrogen atom. So actually, yeah, let's leave it in this form. So let's say it's 49,419 meters per second. So here is the solution of this problem. I hope I helped you. Thank you very much. Bye.